In the last section, we created our first channel. We made the channel, we passed it into the checklink function. Then, after our GET request either succeeded or failed, we then sent a string message into the channel. Then back inside of the main function, we listened for a message and printed it out when we received one. There's just one little issue. We saw that when we ran this code, we only got one log statement and then the program immediately executed. Or excuse me, immediately exited, not executed. So let's dive into this and figure out exactly what's going on. Now, as we start to go through this, this is undoubtedly one of the most challenging concepts around channels. So hopefully we're going to tackle this really hard and get a very good grasp on some of the fundamentals of channels. So let's get to it. Okay, so here's a diagram of our two functions. Here's our main function, and here's our checklink function. So let's kind of walk through this and imagine every line of code as it's being executed. So the main routine starts up as soon as we create our program. We then create our slice of string, we create our channel, we then go into the for loop, and we create our very first go routine. We pass in both the link and the channel to the checklink function. And so we can essentially imagine that our first go routine then becomes live. We'll imagine that the first go routine that comes live is the first element inside of our string of our slice of strings, so google.com. So then our go routine wakes up, it starts to execute the code inside of here, and immediately makes a GET request. So at that point in time, we can kind of imagine that this go routine is now paused like right here. So on that line of code right there. Now the main routine wakes back up and it starts to create the other go routines inside of our program. So one go routine for every other link. Now here is the really critical, very crucial thing to understand. After we create every single go routine, the main routine then says, okay, I'm going to sit here and wait for a message to come through the channel. Whenever we wait for a message to come through a channel, this is a blocking call, a blocking line of code in the exact same way that our GET function over here was blocking as well. So as soon as the Go runtime sees that we want to receive a message from a channel, it says, oh, this routine is waiting for something to happen. There's no other code for it to run right now. We need to just pause and let it do its thing. So the main routine is put to sleep and it says, okay, not going to run the main routine anymore. We're going to wait for something to happen. Then some time passes, and eventually our Go routine, whichever one has the request that resolves first, and in this case it is Google for me personally because that is the fastest website to load. For you, you might have gotten a different result. You might have seen some other result if you had a different connection speed than I. So then the instant the first Go routine resolves the request, that Go routine wakes back up and it starts to execute the remainder of the code inside this function. And so eventually it gets down to either sending this message right here in the fail case or the one at the bottom right down here, the success case instead. So essentially the Go routine wakes back up and eventually sends a message into the channel. Now when this message is sent, the Go runtime then says, okay, looks like we are receiving some data on this channel. Are there any Go routines out there that are waiting for some information on this channel? And the main routine perks up and says, oh, I am. I'm waiting for some message on this channel. And so the main routine wakes back up. It receives the value that we sent into the channel. It prints it out. And then the main routine says, that's it. No other code for me to run. We're going to exit the program entirely. And so the lesson to learn here is that receiving messages from a channel is a blocking thing. It's a blocking line of code. We have to wait for a message to come through before the runtime or before this routine is going to continue on past this line of code right here. And so in practice, we can kind of imagine a diagram that looks like this. So this is a little bit complicated, but let's walk through it step by step. So our program first starts off over here at the very left-hand side. We enter the main routine, we create our slice of type string, and then we enter into the for loop. We then create a handful of different routines. So first is the google.com routine, then Facebook, and then Amazon or whatever other links we have. So immediately after the loop has finished, and we can essentially imagine that the loop is completed at the time that the Amazon or whatever the last link is. So essentially at this line right here, we have now completed the loop and we are now waiting on our channel. So this line right here is meant to represent essentially this line of code right here. So we are now waiting on this. We are waiting for some data to come over the channel. So then all of our different routines are running and nothing on the main routine is running at that point in time. Now, that's kind of an exaggeration of the truth here. The main routine is kind of paused in execution, and truthfully, all the other routines are as well as they wait for the response from our HTTP request to come back. But we can, just in diagram form, we can kind of imagine it occurs like this. So then eventually, at some point in time, Google.com is the first one to wake up and say, oh, looks like we just got a response. And so as soon as we get that response back, the Google routine sends data into the channel. The main routine wakes back up. It then takes that value, prints it out. It finds that there's no other code to run inside that function. And so the main routine exits. And the other Go routines that we have are essentially left off in nothingness, and they never actually finish. They just get terminated entirely. So let's kind of take this to the next degree here, and let's just kind of really figure out and just kind of play around with this a little bit essentially. So I'm going to find our print line statement. I'm going to copy it, and I'm going to put another copy right underneath it. So we now have two locations where we are waiting for a message over our channel. Now I'm going to save this file, and I want you to kind of pause right now, and I want you to think in your head, what do you expect to happen at this point? I just want you to take a wild guess. What do you think is going to happen now when we run our program? Okay, hopefully you've got some idea. Let's now go over to our terminal, and we're going to run the program again. Now this time we get two separate log statements for Google.com and Stack Overflow. Now again, you might see a different order here if your requests are resolving in a different order than mine, which is totally fine. So let's now look at what's happening in diagram format here. Okay, so now this is essentially the same diagram, just with another extra step or two. So I'm going to edit this line right here to actually match up with what I got, which was Stack Overflow. Okay, so now we can imagine that our main routine starts up, it iterates through our slice of string and starts up a bunch of different Go routines. Then our main routine says, okay, I'm listening on the channel, I'm waiting for some data to come across. Then the Google routine eventually finishes. It prints out or sends some data into the channel where the main routine then receives it. So the main routine receives that data and wakes back up. It then prints out the data and then moves on to the next line of code. And the next line of code right here is also saying, wait for some data to come across our channel. And so we enter into the exact same thing again. The main routine then goes back to sleep and only wakes up when, for me, Stack Overflow completed and sent some data into the channel. The main routine then receives that data, prints it out, and then says, no other code for me to write, so I'm going to exit entirely. And so we can start to stack up these print line statements right here and see some interesting behavior. So for me, I have a list of 5 links right here, 5 links. So if I wanted to, I could say, paste out 5 messages to be received here, exactly 5. So now we're going to wait for 5 messages in the channel before we exit this program. So I'll save this, I'll run it, and now we're going to see 5 results here. So 1, 2, 3, 4, 5, then there's no more code to execute, and so we exit entirely. And now we can see some really strange behavior if I place one more log statement here. And so here's number 6, but you and I know that we only are ever going to see 5 messages sent into our channel because we only ever create 5 new Go routines. So now when I save this and run our code, we'll see 5 messages, and then our program just hangs because the main routine is now just sitting there waiting for someone to send some information into our channel. And so personally, I think this is really interesting behavior here. So as you might imagine, it starts to become very critical to think really hard about our channels and how they are set up inside of our application. Now, of course, we probably don't want to have our program just kind of hanging here and running. So let's take a quick break. We're going to come back in the next section, and we're going to figure out how we can print out all the messages that are coming from our channel without having to write out a bunch of different print line statements here. Because obviously, we don't want to have to stack up like 5 print line statements like this, especially if we start to have some different number of URLs in here that we want to print out. Okay, so quick break, come back in the next section, and we'll figure out how we can kind of work around all this channel blocking stuff.